Jacob. And with increasing regulation in the cryptocurrency market, how does VAIOT plan to navigate issues around user privacy and governmental scrutiny? And how does that relate to the ZK-Snarks implementation for VAIOT's AI solutions?
Well, we, VAIOT, happen to be in a pretty privileged situation when it comes to the regulation. I'd like to remind you that, as I said earlier, VAIOT was the first DFAA-regulated digital asset issuer in the entire EU back in 2020. We spent the last 3 years working in a regulated environment. When it comes to protecting privacy and governmental scrutiny, this business as usual for us. The fact that we are regulated makes us think of privacy as a default setting for our solutions, and therefore we follow the approach of privacy by design. Since Maltese public institutions are closely monitoring us due to being a DFA issuer, we make sure that all of our solutions live up to a security and privacy standards. The idea to implement zkSNARKS or AI solutions for business and consumers is emphasizing our dedication to those standards. zkSNARKS will allow us to provide contractual proofs while maintaining the highest level of security and privacy. Now, these proofs, zkSNARKS, are available through our contract reader through optional, additional purchasable certificates. So, if you wanted to take your privacy or transparency of the contract to the next level, besides already being on the blockchain, this is how we're doing.
I see, Jacob. You mentioned the ZK-Snark proofs there. Can you explain the process by which the ZK-Snark proofs are being created?
Well, I'm going to have to transfer this one over to Simon. A little bit too technical here for the marketing guy. But Simon, are you with us yet?
I'm not sure he's in yet. Is it Mix? Oh, well, I can't see him in the list if anyone on the team can see him. Oh, here we go. Just add him in as a speaker now. Welcome, Mix. Oh, well.
Yeah, hello, can you hear me?
We can.
Yes, sir.
Yeah, so when it comes to the implementation of zk-SNARK proofs, in our setup there are two main parts, a prover and a verifier. So let's say you're the prover and you have your contract that states that you buy good X every month. Well, you want to prove this without showing the whole contract, right? You generate a proof using the ZK-Snarks algorithm and your contract as input. This gives us a special proof that says, yes, person A buys good X every month. Then this proof can be given to anyone. We call them the verifier. They can check the proof with their ZK-Snarks algorithm and it tells them, yes, the proof matches up with the statement that person A buys good X every month. Well, the amazing thing is that you can verify this on your own using the deployed smart contract upon generating a ZK-Snark proof. Or you could use our platform, which simplifies the process. The real magic is that the verifier doesn't need to see your original contract or know any other details about it. They just know that the proof is valid, and so the statement is true. So in a nutshell, that's how zk-SNARKs work in our system. That would be the non-technical overview of the whole problem.
Okay, great, Nick. So thanks for explaining that to us. Yeah, I'm not a sort of deep tech person, and we try to keep the spaces sort of high level. So that's great for everyone listening to the spaces to understand it in an easier way. But let's move on. In practical terms, how does ZK-Snarks technology benefit the users of VAIOT?
Yeah, so
I'll take.
Would you like to take this one, Jacob, or should I?
Or we could flip a coin if you want. Depends on what you feel.
Well, in practical terms, we could give an example. Let's say a user has a contract for a lease on a property that they've rented via VAIOT's platform. Now, let's suppose that they want to prove to their bank or potential mortgage lender that they have been consistent with their rent payments for a loan application. Normally, they would need to share their entire rental contract, which may contain personal details they would rather keep private. But with ZK-Snarks, they can generate a proof that confirms they're consistent with their payments without revealing other contract details like the property location, the identity of the landlord, or the terms of the lease. The lender can verify this proof using VAIOT's platform and be assured of the user's credibility while the user maintains their privacy. So in practical terms, zk-SNARKS provides VAIOT users a level of privacy and security that goes beyond what's typically expected. They offer a way for users to verify their credentials without having to expose sensitive information, enabling them to control what information they share and with whom.
I see, Mixoa. Can you provide an example of a real-world example in which VAIOT's use of ZK-Snarks would be particularly beneficial?
Well, I can take over this one for you. Consider an application of VAIOT's technology in the realm of international trade and supply chain management. Today's global trade involves multiple parties: producers, logistics providers, custom officials, buyers, so on and so forth. Most of you are familiar with the whole gambit there. Often these parties require proof of specific details such as project origin, quality certification, or that certain standards or procedures have been met. Traditionally, this provides sharing a lot of paperwork and potentially sensitive business information. Here's where we, with zk-SNARKS, could really revolutionize things. A trade contract could be written, and then zk-SNARK proofs could be generated for specific details. For example, a proof could be made to show that a product meets environmental or labor standards without revealing proprietary production process details. Or proof could be provided to a customs official to show that taxes have been correctly calculated and paid, without disclosing sensitive financial data. This level of granular privacy protection in international trade create a whole new level of trust and efficiency, reducing the chance for disputes and accelerating the trade process. That's the power of applying these proofs to real-world problems at scale, and that's what we're positioned to do.